Hello everyone. Today I shall be explaining the project which I have built for this text mining course. So I am trying to debate on the topic, should soda be taxed? So we will be using text analytics to debate on this topic. So soda taxes, as we all know, also known as sugar sweetened beverage taxes, have been implemented in several cities and states in the United States with varying success. So, as of 2021, there are 13 cities and one state in the United States that have implemented soda taxes. These cities generated around 600 million in revenue in 2018. This revenue can be used to fund public health initiatives, combat negative health effects of consuming sugary drinks. So, research has shown that soda taxes can have a positive impact on reducing the consumption of sugary drinks. For example, after Berkeley, California implemented a soda tax, soda consumption decreased by 21%. In Philadelphia, where soda tax was implemented in 2017, a study found that the tax led to a reduction in the consumption of sugary drinks and an increase in the consumption of water. So, however, soda taxes have also been met with resistance from beverage industry and some consumers who see it as regressive tax that disproportionately impacts low income communities. So it is important to note that impact of soda taxes can vary greatly depending on the specific tax rate, jurisdiction, and socio-economic factors. In conclusion, we can say that while soda taxes have been successful in generating revenue and reducing the consumption of sugary drinks in some jurisdictions, further research is needed to fully understand their effectiveness in reducing sugar sweetened beverage consumption and improving public health. So, we must continue to explore innovative ways to promote healthy behaviors. So, through this project, I'm trying to analyze the sentiment of soda taxes in the public domain. So, through this slide, I would like to discuss my goals of the research using text mining to analyze data related to soda taxes. So, in throughout this research, I have divided the text data into four domains such as soda, sugar taxes, sweetened beverage, and obesity. So my aim is to gain insights into the public sentiments towards these topics by analyzing tweets, news articles, and other related data. To achieve this, I'm using unsupervised learning techniques to understand any hidden topics within these texts and machine learning techniques such as knife-based decision trees support vector machines and neural networks to classify sentences into topics and determine the sentiments. So the information gained from this research can benefit public health advocates, policymakers, and the general public by informing future policies and interventions to promote a healthier behavior. For example, it can provide insights into public perception of soda taxes and related topics, which can inform policies and initiatives aimed at reducing sugar sweetened beverage consumption and promoting healthier diets. So, by using text mining techniques, we can also gain a better understanding of the underlying factors that influence public sentiment towards these topics. So, this can further help us develop more targeted and effective public health campaigns that address these factors. So, in conclusion, my entire research on text mining related to soda taxes has the potential to provide valuable insights into public perception of soda taxes and related topics and inform policymakers. So, I look forward to sharing my findings with you in the following slides. So, let's have a look at the data mining uh, process which was followed for this project. So in this project, we utilized text mining data techniques to extract information from various sources. So data from news websites and Twitter using APIs and web scraping was done for looking at multiple sources of data. To ensure that we had complete information, I used Selenium to extract data from different websites. Pre-processing the data was important to ensure that our results were accurate. So I removed punctuation, tokenized the text data, broke it down into smaller units, and lemmatized and count vectorized to further process the data. These techniques allowed us to understand the information in the data more effectively. So further, I proceeded my research with findings through unsupervised methods. The goal of this particular uh, area of research was to extract meaningful insights from a diverse range of text data sources. The use of unsupervised methods such as k-means clustering and LDA helped us to achieve this goal by providing a way to group similar text together and identify key topics and themes present in the data. Through the use of k-means clustering, we were able to observe that the text data could be broadly categorized into clusters related to health and wellness, healthcare, and medicine technology. So, while the exact meaning and the context of the text data may not be fully captured by this analysis, the clustering results provided a valuable starting point for further exploration and analysis. Similarly, the LDA model identified key topics in the text data, including health and diet, video games, healthcare, and wellness. Furthermore, it also identified topics such as child growth and development. So these topics provided a structured way to analyze and understand the text data, which was which proved to be useful for various applications such as information retrieval and classification and modeling. So overall, the use of unsupervised methods such as k-means clustering and LDA helped to achieve the goals of this research by providing a way to extract meaningful insights from diverse text data sources. So by identifying key topics and themes present in the data, these methods can help to make informed decisions and provide valuable insights in the future. So moving on, I explored certain machine learning techniques such as knife base and to classify text data into these four categories, which is obesity, sugar taxes, sweetened beverages, and soda taxes. So these were the results what I obtained by using the knife base algorithm. Further, after categorizing text into these four categories, support vector machines were used to identify the sentiments from these four categories. So, in order to analyze the sentiment of four different topics related to soda consumption and taxation, I used a technique for classifying text data into either positive, negative, or neutral. So the first step was to divide the data set into separate data sets, such as the four mentioned in the previous slide. So this helped me to analyze the sentiment on each topic separately. So next, I used the Veda sentiment analysis tool from the NLTK library to create labels for the sentiment analysis. So basically, Veda is a lexicon and a rule-based approach that assigns a polarity score to each word in the text and then aggregates these scores to obtain a final polarity score. So I then created a function that takes a sentence as an input and returns a dictionary of polarity scores. So that indicates positive, negative, and neutral sentiment for the text. So to build a final support vector machine model, I further count vectorized the entire data frame as the input, and finally I was able to get the results of the classified SVM model. So finally, the sentiment analysis for each topic was performed separately, and the results were analyzed to understand whether soda should be taxed or not. The analysis showed that the sentiment was generally negative towards the soda consumption, with the highest negative sentiment associated with sugar tax topic. So these findings suggested that implementing a sugar tax could be an effective way to discourage soda consumption and combat obesity. So in summary, for this slide, using SVMs and Vader sentiment for sentiment analysis allowed me to gain insights into sentiments associated with different topics related to soda consumption and taxation. So these were the results for the support vector machine. The highest recall was achieved for the positive category, indicating that the model was able to identify the positive sentiments more perfectly. Although the precision in this category was lower compared to the other categories. So, however, there was some room for improvement, particularly in the positive category where precision was lower compared to the other classes such as negative and neutral. So overall, the model achieved an accuracy of 82% using the using the support vector machines. And in future, in next slides, we can see that how neural networks was used for this particular task. So the text processing for neural networks was similar to the ones what we used in support vector machines, except for the fact that for feed forward neural networks, we also use the count vectorized data frame as the input, but encoded the labels as one hot encoding, so which was necessary for the output layer of the neural network. So furthermore, for the LSTM networks with word embeddings, we use GLOUV embeddings to the input data and one hot encoded labels. So in summary, we explored three different models for sentiment classification and observed their respective strengths and weaknesses. So this entire project highlights the importance of choosing the appropriate data preparation techniques and models for sentiment analysis. So in this next slide, we have highlighted the results from the neural network where we can see that the accuracy was close to 88%. So finally, to sum up all the results we achieved from the sentiment analysis, we could see that there was a comparative analysis for three different models: the logistic regression, feed-forward neural nets, the LSTM, and LSTM with word embeddings. So the logistic regression model had the lowest performance with an accuracy of 86% close to. And finally, we could see that the LSTM networks with word embeddings outperformed the other models, and which was finally used for the sentiment classification. So through this entire project, we could witness unsupervised learning methods and machine learning algorithms that have been proven to be an effective way to gain valuable insights into public perception of solar taxes and related topics. Through the analysis of various text data sources, we were able to identify the key themes and topics related to soda consumption and taxation, and also understand the sentiment associated with each of these topics. The unsupervised techniques we used, including the k-means and the LDA, provided a way to group similar text together and extract meaningful insights from the data. So these methods allowed us to identify key topics such as health and wellness, healthcare and medicine, so which could be used to inform decision making in supervised learning techniques. So further in the supervised machine learning algorithms, we discovered SVMs and neural networks to perform sentiment analysis. And these methods proved to be very effective to classify sentiments on these topics. So the information gained from this research has the potential to benefit public health advocates, policymakers, and the general public by informing future policies and interventions aimed at promoting healthier behaviors. So, for example, the findings of our research can inform policies and initiatives aimed at reducing sweetened beverage consumption and promoting a healthier diet. Additionally, by gaining a better understanding of underlying factors that influence public sentiment towards soda taxes and related topics, we can develop more targeted and effective public health campaigns and interventions that address these factors. So, overall, the use of text mining techniques has the potential to provide valuable insights into public perception and sentiment towards soda taxes and related topics. We hope that this research will inspire further studies in this area and contribute to the development of evidence based policies and interventions that promote a healthier behavior. Thank you.